Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to present our mini project related to emergency roadside strobe light. In the daily life, there is always a problem to vehicle user experience unexpected vehicle failure on the road. Thus, the emergency roadside strobe light can literally save their life. The emergency roadside strobe light is used to inform the user that there is a danger in front of them. This is because the bright strobe light can cut through fog, dust and darkness to warn the road user which can be seen from a long distance. So the priority of this project is to make sure that road users are alert of any obstacle that occur along their journey. This project is planned to solve the invisible of emergency vehicles that often happen on the road. Many vehicles become in trouble when any accident happen on the road where the driver or rider can lose their properties and life. For objective of this project is to indicate the visual warning light, and the second one is to reduce potential hazard that may occur on the road. The third one is to reduce the number of incidents among the road user, and the last one is to develop a prototype system using PCB.
This is our circuit for this mini project. This circuit contains 555 timer, 4017 and LED. The output pin of 555 timer is connected to the input pin to the clock of the 4017. So the signal from the 555 timer will go into the clock of the 4017. Then the signal will go to the LED. However, this LED will be turned on if I close the switch. When I close the switch, the LED start to blinking. Then, by using the VSM counter timer, we can find the value of the frequency that has been used in this circuit. Then, by refer to the waveform of digital oscilloscope, we can find the value of periodic time by subtracting the value of high time and low time. Then, I also use ammeter to find the value of the current that has been used in the circuit. This circuit uses 0.02 ampere. For the calculation part, we can find the value of frequency, periodic time, time high, time low, duty cycle and power consumption by using the value of capacitor R1 and R2. This is the comparison between the calculation and simulation based on this parameter. Based on this comparison, we know the calculation value is approximately same with the simulation value. Time high is the condition when the LED is turned off, and time low is the condition when the LED is turned off.
Alright, now I will continue with the PCB layout of our project. What is PCB layout? Printed circuit board, or we call PCB, consists of a board with copper trace and numerous components attached to conduct electricity through the circuit. It made from substrate and base material. was simpler to design using design nesting software, which is in this assignment we use Proteus software. The copper layer is prepared by etching and then solder the various components onto the board. It was lesser chances of error when we use PCB layout in order to make a prototype of our system. Alright, this is the PCB layout of our project. This yellow box indicates the size of PCB where we can create it by select 2D graphic box mode. Our circuit need to be drawn in this box. After connecting all the circuitry elements, the track option is used to create the track and connect all the components. If there is a flaw in the design, it will indicate by red color circle. Lastly, Proteus also have the tool that can show 3D visualization of the circuit. It can be produced by click on 3D visualizer. Alright, this is the 3D visualization of our circuit. It consists of all angle view. This 3D visualizer can give some picture to us about how our circuit will be. Alright, this is the back layer view, which is the connection that we create. So when we want to do the prototype, we will do the soldering in this hole where we place on the component. So and this is the final look of our design.
In the discussion, this LED has 68 milliseconds of periodic time and 40.7 Hz of frequency. It has 35 milliseconds for time high and 33 milliseconds for time low. So, the LED will be turned on in 35 milliseconds and it will be turned off in 33 milliseconds. This system also has 0.27 watt of power consumption, so it uses a low power consumption. This circuit also can be used as a portable system, so it allows the user to apply it on the roadside. Furthermore, the LED has a color of red, so it will attracting everyone's attention and it's easy to identify.
For the conclusion is, the circuit design for emergency roadside strobe light was completely done with the help of Proteus software, included the PCB layout. The result of this circuit simulation have been tested and recorded for the future analysis. Thus, this circuit, which is this roadside strobe light, is used to warn the driver of descent to initiate an appropriate driving response. That's all from our group. Thank you.